Hello everyone. In this lecture, we will solve one of the problem from congestion control mechanism. So we can see that a TCP sender has a congestion window size. See, this denotion is congestion window size 1 MSS initially, and this is threshold. Okay, threshold is already mentioned in 8 MSS. See, if threshold is not in a question, if threshold is not mentioned, then definitely a receiver window size will be mentioned. Okay, and if the receiver window size is already mentioned, then you can divide it by 2, then you will directly get threshold. But here in this question already mentioned, then you don't have to compute it. If there is no threshold mentioned, then definitely there would be a receiver size mentioned, then you can directly compute it. Okay, fine, you know all those things. Now a connection increases the window using a slow start phase until it reaches the threshold, and after that which it switches to a congestion avoidance phase. See, this all entire is a definition of congestion control mechanism, nothing new. It will start with slow start phase, means it will start from 1 MSS because initially it is 1 MSS, then it will exponentially grow, means 2 raised to power 0, then 2 raised to power 1, 2 raised to power 2, then 2 raised to power 3, right? Like this it will grow exponentially till what? Till threshold. Then after that it switches to congestion avoidance. When it switches to congestion avoidance, when it reaches to threshold, it will switch to congestion avoidance. It get into, then in congestion avoidance it will grow linearly. Okay, that's it. That is the question. And at the between there is a timeout timer. So what you will do? See, at the beginning it will start with 1 MSS. Otherwise, if you are getting confused, first write all the given. Congestion window size is 1 MSS. Okay, if it is given in kb, convert into 1 MSS. For example, in exam, if congestion window size is written as 1 kb, then what you have to do is directly convert into 1 MSS. Consider 1 kb is equal to 1 MSS. Okay, and solve the problem. Convert everything into 1 MSS and solve the problem. Everything would be very easy. Instead of this MSS, if kb is given. Okay, right? Fine. Hope you understood, right? Now, threshold. What is the threshold? Threshold is given 8 MSS, right? And nothing new, right? Now it will start from 1 MSS, which is 1, then slow start phase. At the beginning it is slow start phase, right? So 1, then after that 2, then after that 4, then after that 8. Yes, means 2 raised to power 0, then 2 raised to power 1, then 2 raised to power 2, then 2 raised to power 3. So this is called exponential growth. Till how? So till which till what amount it will, so till what amount it will grow? Till 8, until it reaches the threshold. Okay, so at this is the threshold, we made to the threshold. Okay, so this become a threshold, this part is threshold, right? Now after threshold, what will happen? After threshold it will linearly grow, means 9, then 10, then 11, then 12, then 13. Like this it will linearly grow. Okay, until what? Until it reaches the receiver full capacity, receiver buffer size. But here we are receiver buffer size is not even mentioned. Okay, so you don't have to worry about all those things. Read the question now properly. Timeout occurs at 9th transmission. Okay, so 9 transmission, this is first transmission, then second, then third, then fourth, then fifth, then sixth, then seventh, then eighth, then ninth. Yes, so this is the 9th transmission, right? At this time timeout occurs. So at this time timeout occurs. Then what you will do? If there is a timeout occurs, then I told you it's called a, see, congestion detection has 2 phases, right? Timeout and 3 duplicate, right? If timeout occurs, that means the congestion is very severe. Okay, then we have to calculate one threshold, new threshold. A new threshold will be 13 divided by 2, and it would be seal. Remember this. Okay, sorry, it will be floor, not seal, it is floor. Okay, then what would be the answer? It will be 6.5 floor, then answer would be 6. So the new threshold is 6. Then what will happen after this? It will enter into, when there is a timeout occurs, then it will, after calculating the new threshold, it will enter into the slow start phase. The slow start phase is, it will again start from 1 MSS, then 2, then 4, then 8. But you have to look at the threshold. See, it will not directly get into 8. See, when it start from slow start phase, then it should go from 2 raised to power 0, exponential growth, right? 2 raised to power 0, 2 raised to power 2, 2 raised to power 3, then 2 raised to power 2, then 2 raised to power 3, right? But now our threshold is 6, so it will not go to 2 raised to power 3, that is 8. It will directly jump to 6 only. Okay, so it will directly jump to 6. That is what it returns. Slow start. See, window using a slow start until it reaches the threshold. So until it reaches the threshold, it will keep on growing exponentially. So when it reaches the threshold, okay, so this is a slow start phase. This is also a slow start phase, because we have calculated a new threshold. And after the new threshold, it will switches to congestion avoidance phase. That means it will slowly grow. Slowly grow means after that 7, 8, 9, 10, like this it will keep on doing a linear growth unless and until it reaches the receiver maximum window size. Okay. Now read the question again. See, in the question it is written, compute the congestion window at the end of the 12th transmission. So that is the question. So 12th transmission means first transmission, second, third, then fourth, then fifth, then sixth, seventh, eighth, 9, 10, 11, then 12. Okay, so 12, right? I will calculate again. First is 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, 9, then 10, 11, then 12. Okay, so we are at 12. This is 12th transmission. So after 12th, it's asking after 12th, right? Compute at the end of 12th. End of 12th transmission, what would be the congestion? So after end of 12th transmission, the congestion window size is now 6. Right? The answer is 6 MSS. 6 MSS.